Hello everyone. In this video, we will talk about the IUPAC nomenclature of Spiro compounds. I have already made two videos about the IUPAC nomenclature of bicyclic compounds. The links are given in the description. In case if you are not familiar with the IUPAC nomenclature of bicyclic compounds, then it will be somewhat difficult to follow this video. Therefore, I recommend that you watch those videos first. In principle, Spiro compounds are indeed bicyclic molecules because you need to break two bonds to make them as an open chain structure. However, their nomenclature is slightly different as they have only one common atom, unlike the bicyclo compounds. So let's discuss the similarities and differences first in terms of nomenclatures. So as you know, in the bicyclo case, you have two bridgeheads. Basically, you have two common atoms. So in the bridged one, they are not adjacent to each other. In the fused case, they are adjacent to each other. Okay. So in the Spiro case, you have only one common atom, which we call it as quaternary carbon or 4-degree carbon. Okay. So here you have two common atoms, and here you have only one common atom. And then the numbering, whatever the numbering that comes in the square bracket. So in the case of bicyclo, the numbering goes from largest to smallest, from one side of the ring to the other side. So here it goes largest to smallest, and here whatever comes in the square bracket, it goes the opposite way, smallest to largest. So Spiro smallest, that's the way you can easily remember. Yeah, S and S. Okay, so that's easy to remember. Smallest to largest. So basically, here the secondary prefix is bicyclo. So bicyclo, and then the numbering in the square bracket, and then the parent chain. So here that secondary prefix is Spiro, not bicyclo. So Spiro, then the numbers in the square bracket, and then the parent chain. And for bicyclo cases like bridged and fused, the numbering starts from the bridgeheads. So numbering starts from the bridgehead carbon atoms. So basically, if you are numbering the bridged case here, you will be numbering 1 here, 2 here, 3, 4, 5, 6, and then 7. That's the way it goes. But in the case of Spiro, it goes adjacent to the quaternary carbon. So basically, you have to number either from this side or that side. So it's adjacent. So 1, 2. Here this molecule is very symmetric, so you can basically number from anywhere. So let's just complete this. 1, 2, 3, 4, 5. You can either go clockwise or counterclockwise. So numbering in this case starts adjacent to the 4-degree carbon. So let's keep this in mind, and let's work on few examples. So let us say we have a molecule like this. So let's find out the IUPAC name for this molecule. So you first write down your secondary prefix no substituents. So Spiro, and then number from here 1, 2, 3, 4, 5, 6, 7. So 2.4, 2 carbon atoms here. So basically 2 carbons here and then 4 carbons here. So that's what we wrote. So Spiro 2.4, total 7 carbon atoms in the parent chain, so heptane. So that's the IUPAC name. So let's discuss more examples. Let us say we have a molecule like this. Then one bromine here, one aldehyde group there. So how to number it now? So just because the functional group is here, it doesn't mean that you should starting one from there. You shouldn't. You should number the smallest ring first. So 1, 2, 3, 4. Now you have to start continue numbering on this direction because that gives the lowest number for the aldehyde. So 4, 5, 6, 7, 8, 9. So the IUPAC name is gonna be 1 bromo and then Spiro and then 3.5 because basically you have a 4-membered ring here and a 6-membered ring here. Nonane 5 carbaldehyde because that's your functional group. Let's look at one more example. Let's say you have a structure like this. One isopropyl group, one methyl group, and then you have another 5-membered ring, there one ethyl group. So now how to begin the numbering? You have 5-membered rings on both sides. So if you start numbering from here 1, 2, 3, 4, 5, 6, 7, 8, 9, that IUPAC name would be wrong because there is another way you can number it where you can give lowest numbers for the substituent. So basically I'm just going to change the color. So let's say if you start numbering basically starting from the isopropyl group first, 1 and then 2 and then 3 then 4 and then this is 5, then this is 6 and then sorry, so this becomes 7, this becomes 8, this becomes 9. So here you have substituents at 1, 4, 6 position. So basically this one has the low priority for the substituents. So therefore you have to use this one. So the IUPAC name is going to be 6 ethyl. Now here you are once again following the alphabetical order for the substituents. So 6 ethyl first, so you have to mention the ethyl group that is there at the 6th position, and then 1 isopropyl. Remember the iso is counted for the alphabetical order thing. If it is secondary butyl, then only butyl is counted, not that ACC, that is not counted. So, but for isopropyl, the iso is counted for the alphabetical thing. So, therefore, this is correct. Don't think that the propyl is the methyl should come first, isopropyl should come next. No, that's not correct. And then 4 methyl Spiro 4.4 because they are 5-membered rings, nonene. That's the correct IUPAC name for this. I will just give you one example as a homework. So if you do figure out the IUPAC name, just write it as a comment. So let's say you have a structure like this. So write down the IUPAC name for this in the comment. Thanks for watching this video. If you do like this video, consider subscribing to Chem Media. Thank you.